Okay, so now let's find how to solve an integral without having to use area. So sometimes you do have to use area, and sometimes you don't have to use area. So as we learned previously, the area function, if you need to jot this down somewhere, if you don't already have it written down, you might want to jot this down. Capital F of x is the area function, which is the antiderivative. All right, so let's evaluate the indefinite integral. So you can pretty clearly see what the difference between an indefinite and a definite integral are. A definite integral has bounds. An indefinite integral does not have bounds. So indefinite integral just means find the area function. Find the general area function. Just like when we were calculating derivatives, sometimes we would find the slope function, aka the derivative, and sometimes we would find the slope function at a point and we plug in like a number. So same thing here. If you find the area function, that just means find the general function. And if you're finding the area function between two values, then you're actually plugging in the numbers. So the area function is the antiderivative. So let's do power rule backwards. If I start with x squared, then my antiderivative would be x to the third. And then if I were to take the derivative and to get 1 in front, I would have to multiply by 1/3 because, again, you're multiplying the power in front. 3 times a third is 1. Subtract 1 from the power, I get x squared. So please make sure when you're finding antiderivatives that you are checking your answer. All right, the antiderivative of 3x, so the antiderivative would be x squared. And then I'd have to multiply the 2 in front but get 3. So how do I multiply 2 in front and get 3? I have to multiply by 3/2. And then the antiderivative of -4 is -4x, because the derivative of -4x is -4. And then here's the tricky part. You can't forget plus c. Because remember, there's kind of like an invisible plus 0 here. The antiderivative of 0 is c. The antiderivative of the derivative of any constant is 0. Therefore, you need to have the plus c. Okay? And then that is your answer. There's nothing else to do. Just find the antiderivative and don't forget your plus c. Now for number 6, we have a definite integral, but the first step is going to be the same. We're going to start with the antiderivative. So the antiderivative of 3x squared is going to be x cubed. And then you would multiply the 3 in front, which it already has, so we don't have to do anything different here. The antiderivative of 4x is something x squared. If you multiply 2 in front to get 4, you'd have to multiply by 2. And then minus 2, so the antiderivative of -2 is -2x. Okay, now I'm going to show the plus c part, but you actually don't need to put plus c. And you'll see why in the future. You will never see me do a plus c ever again. This is the only time I ever show a plus c. And the reason is, yes, plus c is part of the antiderivative, but if you are solving a definite integral, the plus c will actually disappear. So let's show those steps. So here's a notational thing. In this step, with a definite integral, you need to keep the bounds. And this is where you need to write them. At the end, on the outside of brackets, or you can do your work like this. You can write the equation. And again, you don't really need a plus c, from 1 to 2, and you just drew like a big vertical line, and then lower bound 1, upper bound 2. Make sure if you are solving an integral, you find the antiderivative and you put the bounds on the right-hand side. Because if you do not and you put them on the left-hand side, that's not a proper math notation that we know, and you'll get confused. I'll get confused. Like, is it still an integral? Have you found the antiderivative yet? So the first step is find an antiderivative with the bounds on the right-hand side. Okay. Then you plug in your upper bound. And you're going to plug in your lower bound. And you are going to subtract. So if you remember from the previous lesson where we came up with what the area functions were, it was always like 3b minus 3a, or 3/2 b squared minus 3/2 a squared. So it's always going to be a subtract. Plug in your upper, plug in your lower, and subtract. Now you can see why even though I put a plus c here, you actually don't need it if you have a definite integral. For an indefinite, you do need it. But for a definite, you kind of don't, because c minus c just cancels, right? That's why you don't need to put a plus c. All right, and then I have 8 plus 8 minus 4 minus parentheses. Please keep parentheses when you are subtracting. You're subtracting your lower bound. So 1 plus 2 minus 2. So that's going to be 16 minus 4 is 12. Minus 1 plus 2 minus 2 is 1. And so my answer is 11. And again, you don't have to write units squared for it when you're solving an integral, okay? So the steps were: find the antiderivative, make sure you use one of these two notations. I don't care which notation you use, brackets or like this line over here, but make sure you have your bounds written. Then plug in your upper bound, plug in your lower bound, and subtract. Okay, so antiderivative, plug in your upper, plug in your lower, subtract. Those are your steps.